Good? All right, so here's what we're doing. We are talking about chemical reactions. That chemical reactions, they have reactants that are distinct from the products. So whatever products we produce are different from the reactants that we started with. Often, chemical reactions produce a gas as one of the products. What are some of the signs that we would see a gas?
Steam, or like...
Yeah, we talked about some,
Oh,
like
yeah,
we
yeah,
might be
yeah.
able to see some of that vapor. What else?
Yeah.
Remember?
Bubbles.
Yeah, and we talked about bubbles. That if we're producing a gas in a solution, we're gonna be able to see bubbles form up from that. Did we talk about anything else? No, bubbles was kind of the big ones that I was looking at. One of the reactions that we do, we are gonna produce bubbles. There's gonna be a solution, and hydrogen gas is gonna bubble out of that, so we're gonna see it. The first one we're gonna do here is the decomposition of baking soda. So I'm gonna put baking soda in here. And the decomposition reaction means that we're starting with some reactant, and that reactant during the chemical reaction is going to break apart into component parts. So right here, this is our reaction, the first one, baking soda. The decomposition, it's gonna split up into its component parts. One of those products is gonna be carbon dioxide. Carbon dioxide is a lot more dense than air is. So if that's one of our products in this test tube, it's just gonna sit at the bottom of the test tube. It's not gonna float up and away. So we should be able to capture it real easy in there. What we're gonna do with that, once we capture that, is we're gonna take a burning splint with the flame on it, we're gonna put it in there. What is that flame gonna do when it's in the carbon dioxide? What's it gonna do?
Blow out.
It's gonna go out. What's in the fire extinguisher?
Carbon and...
Yeah, often, yep. So we put it in there, it's gonna essentially smother it, because then it's not gonna have that oxygen gas to be able to keep burning. So we'll do that like this. Oops. Right there. And we're gonna give that a minute or two as it does the chemical reaction, because all it needs is a little bit of heat to get that going. We should, because one of those products, another one of the products is water. If we let this go long enough and if we were looking carefully, we would also be able to see condensation forming on the inside of that test tube, because as water was being produced, and then that water would be hot by the Bunsen burner flame, it would then turn into a gas, but when it hit the cooler air outside around it, it would then condense. So we could also potentially see water as one of those products there. But this gas test that we're gonna do with this, that's a test that's gonna tell us if it is indeed producing carbon dioxide and it's not producing like oxygen gas or hydrogen gas or one of the other things. All right, should we try it? And there it goes out right away.
Wow.
And if we lit it again and put it back in there, it would go out again. Okay, so that's the first reaction, producing carbon dioxide and then testing for that carbon dioxide to see if it does smother the flame. Let's do, might as well go in order. So let's do this next one. So HCl plus zinc yields hydrogen gas and zinc chloride. What kind of reaction type is this? Out of the 5 reaction types that we saw, that we looked at, what type is this? We've got a pair right here, and then we've got a single. And what is that single doing here?
Splitting.
It's displacing it. So what kind of reaction type is this?
Displacement.
Single displacement, because we've got this pair right here, and then that zinc is coming in and displacing the hydrogen. It's just swapping partners right there. Well, just the one right there. So our product is gonna be hydrogen gas and zinc chloride. So same thing we're gonna do here is we're gonna produce hydrogen gas, and then we're gonna use the flame to be able to test for that. So I need those 2 reactants. I'm gonna put my zinc right in here. The reaction's gonna happen in this film canister, And I need a way to capture it because zinc's a lot less dense than the air is. So if we did it in a test tube like that, it would just float up and away. So we're gonna capture it in this pipette bulb. I'm gonna fill this totally with water so we know when we've got the hydrogen gas. It's gonna displace the water as it produces that. Either anyone here hold that? Are you okay with that? Okay. Okay. So we should be able to see bubbles here. Look at that right away. So that's hydrogen gas is being produced. It's displacing the water in the pipette bulb. And now this pipette bulb is filled with hydrogen gas. What does hydrogen gas do with a flame?
It explodes.
Yeah, it does. This one's kind of a little bit lame, but we're gonna get a little bit of a pop. You can still hear it though. Nope. There we go. Okay. That wasn't bad.
Dang, bro.
There we go. So we heard that little tiny pop explosion. Okay, last one right here is decomposition of hydrogen peroxide. So this is something that happens on its own. That's why it's in the brown bottle. And this is the same stuff that you would buy. It's 3% hydrogen peroxide. It's in the brown bottle because it would, with light, that would make that decomposition reaction happen faster. So the brown bottle is trying to prevent that, so you would have your hydrogen peroxide last as long as possible. So if we put it in here, that light's gonna help that reaction happen a little bit faster, but still not very fast. It's still gonna be pretty slow. We would be sitting here for a long time. So we wanna add something to make that go faster. It's not actually a reactant, it's just a catalyst that's kind of jump-starting that reaction. I need one more set of hands. Who wants to do it? I'm gonna hold up the top here. So hold at the top, because this down here, when this reaction happens faster, when this decomposition happens fast, it's gonna produce heat. So if you were holding it down here, it would probably get warm enough that it would be uncomfortable and it would surprise you and you drop it. It's not gonna get hot enough to like burn you or anything. So I wanna have that ready to go too. So we're gonna add this manganese dioxide to catalyze it. Right there. And the oxygen gas that it's producing, is ever so slightly more dense than regular air, so it is gonna sit at the bottom there. Okay, if we let this burn and it's producing oxygen gas in here, and then we blow it out where there's still embers and then put it in, what is it gonna do?
Light up.
It's gonna light back up. Because what do you need for fire?
Oxygen.
Oxygen. We already used it all up. But those are our 3 gas tests. Thank you very much. And do you want to feel how hot it is down here?
End it?
Yeah.